What's up, kids? Welcome to another fun-filled day of science. Today we're going to be learning about density. I'm going to read a story about the history of density. Once upon a time, far, far away, in a distant land, about 250 BC, there was a king named King Syracuse. He hired a gold craftsman to create a crown for him. He wanted the crown to be pure gold. The king received his crown from Amazon. He was elated, so he began to try it on his head.
This is my crown.
The king was skeptical. He was thinking, how do I know this is pure gold?
I'm not sure I'm going to give a 4-star review on this. I don't think that's real gold.
While he was an arrogant king, he didn't trust very many people, so he thought he had been cheated.
Seems awfully flimsy to me.
Everywhere the king went with that crown on, people were making fun of him behind his back.
I need to hire somebody to test this. I feel like I must have gotten ripped off.
So with this thought in mind, King Syracuse hired Archimedes.
Archimedes, appear!
He wanted Archimedes to figure out if the craftsman had created the crown out of pure gold.
I've brought you here on the account that I ordered this on Amazon Prime, one-day delivery, and I'm not entirely satisfied with the quality. Is there any way you could tell if this was made with real gold? Like, let's test the density of this.
Gold is much more dense than silver. The king had a few rules. He did not want the crown to be damaged, so it could not be melted to see if there was any silver in it. Archimedes thought about this problem, and he thought about how to solve it. So one day, he was taking a bath. He sat in the bath, and he saw that the water had spilled over. The water was displaced. In order to find out density, you need two things. Mass is easy. It's the weight of something. But we need to find the volume. That's where water displacement comes in. Archimedes knew the density of gold. He also knew the density of silver. He needed to find out the volume. So he took his idea of water displacement to find the volume of the crown. He dunked the crown in water to see how much water was displaced. That's when he realized the densities were off. The crown was not pure gold. It's never a good idea to steal from a king. From this, he knew King Syracuse had been cheated. With that information, he ran all the way to King Syracuse to alert him of the news. The crown was not pure gold. That was an insult to King Syracuse. The king summoned the gold craftsman to call out his treason. And now you know the rest of the story. The end. Think density. It's your destiny. All right, to find density, we use a formula. Density equals mass divided by the volume. So, to get the mass of an irregular object, that's pretty easy. I can just throw it on this triple beam balance and get the mass. Look at that. Triple beam balance gives you the mass. This is typically how you find the volume of a regular sized object that has straight edges. You can use a ruler. That's very simple. You just measure length times width times height to get the volume of a regular sized object, like this. There's no flat edges on this rock. I can't measure the volume using this ruler. That's why I gotta use water displacement and volume. So let's measure where the water is in this graduated cylinder. If you see, it's at 50 milliliters is the starting point of the water. So the next thing I want to do to get the volume is place the irregular object into the graduated cylinder, and you will see water displacement. Went up to about 55 milliliters. So we have a beginning volume and we have the volume once we've placed the irregular object in the graduated cylinder. So we simply take the first volume and subtract it from the new volume. So 55 minus 50 gives us 5. So we have the mass of the irregular object, which is rock. And we also have the volume. We got the volume with the starting water, which was 55, dropped in the irregular object. It rose to 55, so we subtract the original volume from the new volume, which gives us 5 milliliters. All we have to do now is plug in the formula. I'm not asking you to do all this math in your head. Use your good old trusty calculator. So we take the mass, 11.8, divided by the volume, which was 5, gives you your answer. Density equals 2.36 grams per milliliter. Look how easy that was. Now you know the density of this rock.
Ooh, science.